In this video, we will be working with sides and angles and midpoints. So given EQ is congruent to ET, Y is the midpoint of QT, EW is congruent to ER, prove WY is congruent to RY. We'll go through the proof down here and put it on the diagram up here. So EQ is congruent to ET, given EQ is congruent to ET. Y is the midpoint of QT, given EW is congruent to ER, EW is congruent to ER over here, WQ is congruent to RT, subtraction property. If we subtract these congruent segments from these congruent segments, we end up with congruent segments here. QY is congruent to TY, definition of midpoint, so QY is congruent to TY. Next, angle Q is congruent to angle T if sides then angles. If we have these two sides congruent, the opposite angles are also congruent if sides then angles. This is a theorem you might have gotten to in class. You might not have if it's early in the year. It is used with isosceles triangles. Next, triangle WQY is congruent to triangle RTY, SAS, side angle side, side angle side, side angle side. From there, WY is congruent to RY, CPCTC. Corresponding parts of congruent triangles are congruent. We'll do this in red just to set it off. WY is congruent to RY, and that is the proof, and we are done.